proof. So I have angle 1, angle 2, and angle 3. It tells me given angle 1 is congruent to angle 3, I need to prove that the lines are parallel. If I'm trying to prove lines are parallel, the only options that you can put is some sort of converse for this last step. So the first one says angle 1 is congruent to angle 3. Angle 1 and angle 3 are corresponding angles, but I cannot use corresponding angles converse. The first step is always what is given. So angle 1 is congruent to angle 3. The reason why I know is because it is given. The next step says angle 3 is congruent to angle 2. The reason why I know these are congruent to each other is because vertical angles are congruent. So whatever is here automatically jumps across the intersection. These are vertical angles. So vertical angles. Theorem. Vertical angles given. The next one says angle 1 is congruent to angle 2. If you know your vocabulary, technically these are alternate exterior angles, but that's not an option. Alternate interior or exterior angles converse is used to prove lines parallel. So what they want for this step is they want transitive property. The reason why is because they say angle 1 is congruent to 3, 3 is congruent to 2. So they're removing this middleman and they're sticking the back and the front congruent to each other. That is transitive property. It's removing the middleman. And then you can justify L is parallel to M because you're always taking the previous step and connecting it to this step. Angle 1 and angle 2, just like we just talked about, are alternate exterior. And we're going to use this one converse to prove that the lines are parallel. This has to be a converse. So alternate exterior angles converse. That is used to prove lines are parallel. Number 2, you have two lines that are parallel, cut by a transversal. It says Peach Street and Cherry Street are parallel. So this is parallel to this. Apple Street intersects them. That's your transversal, as shown in the diagram above. Angle 1 is 4x minus 5. I'm going to put this in my picture. The measure of angle 1 is 4x minus 5. The measure of angle 2 is 13x minus 2. I need to find the measure of angle 2. So I need to decide, do these two angles add to make 180 or do they equal to each other? If I look at how much the angle is opening, I have this little acute angle. It's itsy bitsy, it's teeny weeny. And then I have this massive obtuse angle. These are not the same opening. They are different from each other. So because they are different, they are supplementary. Because technically you could move this up here because corresponding angles are congruent, and then they would be a linear pair. So they are different. They're not the same. So we're going to add them together. And we're going to equal them to 180. So if I combine like terms, 4 and 13 add to make 17x. Negative 5 minus 2. If I add them together, negative 5 plus negative 2 is negative 7. Bring down equals 180. And then it's a two-step equation. So the opposite of minus 7 is plus 7. 180 plus 7 is 187. And then last step is to divide. X equals 11. Now, because it wants to know the angle measure, I have to substitute it back in. That's the value of X. I'm going to plug it back in to find angle 2. Angle 2 is 13x minus 2. I'm substituting 11 in. So I'm doing 13 times 11 minus 2. 13 times 11 is 143. And then I minus 2 from it. So 141. The measure of angle 2 is 141 degrees. On the back, it says, for what value of X will F be parallel to G? So F and G, we need to figure out what X has to be to make them parallel. So this is an exterior angle. This is also an exterior angle. They're outside of the parallel lines, and this is your transversal. They jump across the transversal. So because they jump across, they are alternate exterior because they're outside angles, converse. The reason why it's converse is because we're proving them to be parallel. So we're going to set them equal to each other because they're both obtuse. Alternate exterior angles are congruent. So we're going to say 10x plus 5 equals 12x minus 9. You could minus 5 to both sides, but I'm going to get rid of my negative. So I'm going to add 9 because negatives make your life difficult. So I have 10x plus 14 equals 12x. Now I need to combine my x's. Because 10 is positive, I'm going to subtract it to the other side. 14 equals 2x. Last step is to divide. So x equals 7. Number 4 says if 6 is congruent to 8, so they're saying that they are congruent. 6 and 8 are congruent. Here's 6. Here's 8. They are congruent. Can you conclude that the lines are, any of the lines are parallel? Explain. So these are parallel, or there's a set of parallel lines. The reason why is because these are corresponding angles. They're in the same spot, slid over. Now, if you look, these are both falling on, you have G and H. Six and 8 only fall on H in this case. They don't fall on G. If I color these ones, P and Q, they both fall on P and Q. J is neither because 8 does not fall on either of them. So that one's automatically out. So because P is being used and Q is being used, you can say that 6 and 8 are parallel, or 6 and 8 are corresponding. And the reason why is because P and Q are parallel. P and Q are parallel because of corresponding angles. So it'd be C. So you can't use G because nothing falls on G. 5 says line M is represented by y equals 2/5 x plus 4. Match the equation to the term that accurately describes a relationship to line M. So you're comparing your slope. Parallel lines have the same slope. Perpendicular lines have opposite reciprocals. So parallel is equal to the same. Perpendicular is opposite reciprocal. So if I look at my slope, I'm looking for 2/5. This is -2/5, -5/2, 2/5. Since it's exactly the same, it matches exactly, that's going to be your parallel equation. These last two, there's going to be one that's opposite reciprocals, and there's going to be one that's neither. So 2/5 just makes it negative. It does not flip it, so that's neither. And then if I make it negative and I flip opposite reciprocal, that's going to be perpendicular. 6 says, what is the equation of a line perpendicular? So we need opposite reciprocal slopes to the line 1/2 x plus y equals -7 and passes through the point 4, 3. So this is where we're going to use point slope form. So if I move my x over, I'm going to minus 1/2 x, minus 1/2 x. I have y equals -1/2 x minus 7. Now my slope was -1/2, but that's going to change. -1/2 flips and becomes positive. So that's my new m. And then I'm going to use that in point slope form to plug it in. Point slope form is y minus y sub 1 equals m times x minus x sub 1. So if I plug in m and I plug in my point, I'm going to plug in my values. The first y stays exactly the same. Y1 is 3 equals my slope, which is 2/1, which is really just 2, but I'm going to put it as 2/1. And then in parentheses, x minus 4. So now I'm going to use the distributive property and distribute. 2/1 times x is just 2x. 2 times -4, or 2/1 times -4 is -8. And you should be using your fraction button. Last step is to move the 3. I'm going to add the 3 to both sides. So that is A. 7 is a review problem. 7 says EF is upside down capital T, which is perpendicular, that's 90 degrees, to FH. So that means that this line and this line make a 90-degree angle in total. Together, it makes 90 degrees. EFG is x minus 1. GFH is 5x minus 5. I have to find EFG, so I'm going to have to plug it back in because it wants an angle measure. So first thing I got to do is solve for x. So since this is a total of a perpendicular intersection, we're adding to make 90. So we're going to do x minus 1 plus 5x minus 5 equals 90. So if I combine my terms, 1x and 5x makes 6x. -1 and -5 make -6 when they come together. I'm going to add 6 to both sides because the opposite of negative is positive. And then I divide. So x equals 16. Then I substitute it back in because I need to find EFG. EFG is this slice of phi. So I'm plugging it back in. If x is 16, 16 minus 1 makes a total of 15. So your small angle is 15 degrees. 8 says, what is the equation of a line that is perpendicular to 1/3 x plus y equals 5 and passes through the point 2, 1? So I made an extra problem of number 6. This is another example of number 6 that we could practice more. I think this is the hardest problem on the test. So I'm going to move the 1/3 first. It's positive. So I'm going to subtract 1/3 x to both sides. I have y equals negative 1/3 plus 5. Because it's perpendicular, they do not have the same slope. So I take my slope out and I have to change it. I need the opposite reciprocal. So if it was negative 1/3, I flip it and I make it positive. So 3/1, which is really just 3. We're going to use our point, which is x1 and y1, to plug it into point slope form. Point slope form is y minus y sub 1 equals m times x minus x sub 1. So if I plug in y sub 1 is 1. I'm going to plug in the slope, which is 3/1. Then in parentheses, I have x minus 2. Now I can distribute. 3/1 times x is 3x. 3/1 times negative 2 is negative 6. And then I have to move my 1 over. So I add 1. Nine, I made an extra problem of the number 7. So it's just extra practice because these are the ones that you get bad at because you got to like do algebra stuff. So it says EF is still perpendicular to FH. This is 90. So same thing. These come together to make 90 degrees in total. It says EFG is x plus 8. GFH is 7x plus 2. I need to find EFG. So this time, whenever I plug it in, or wait. I think it wants both. I'm going to do both. So I'm going to plug it into this one because that's what the little blankety blank says. So I'm adding to make 90. So I'm doing x plus 8 plus 7x plus 2 equals 90. I combine like terms. 1x and 7x make 8x. 8 and 2 are both positive. They make 10. And then I minus 10 to both sides. So I have 8x equals 80. And then I divide by 8. So x equals 10. If I plug it back into EFG, EFG is the skinny piece. If x is 10, 10 plus 8 makes 18 degrees. And then I forgot to change this. So E when I made the extra problem. GFH, the bigger slice, if I plug it in, I'm doing 7 times 10. And I'm adding 2 because I'm plugging it into this equation. So that's 70 plus 2 is 72. The last two are really just vocabulary. So it says match each segment to the term that describes how it's related to AB. So I'm looking at line AB. AB is this back line. One of them is going to be parallel. One of them is going to be intersecting, meaning they cross. One of them is going to be skew. Basically, it's not parallel and it does not intersect. So let's try to see which one is parallel first. So they're saying C to E. CE is this one. BE is this back one. C to D, that would be parallel to AB. So CD is parallel. If I look at the last two, intersecting means they're going to cross. So I'm still looking at AB. AB. I'm looking for something that intersects. CE goes this way. Those do not intersect because you have to remember this is like a 3D shape. It would intersect with BE. They cross, they touch right here at B. So this is intersecting. Skew would be, because AB is this back piece. This is a 3D shape, so that would never cross with CE. Yes, they cross right here, but it's a 3D shape, so they're not actually crossing. Last one is 11. Same thing, you're matching them. So we're looking for something parallel to AB. So if I look at AB to start, the bell's about to ring. So here's AB. I need something parallel to this. My options are F, G. Where's F, G? Oh, F, G's here. Those are parallel. They do not cross. And they run parallel to each other. If I look at AD, so I'm still comparing AB to AD. AB to AD, they cross at A. So that's intersecting. The last ones, if I'm comparing AB still, AB to ED, ED's back here. They would never cross paths. So they are skewed.